A solution to our class 10 higher mathematics syllabus cover board of secondary education Manipur. Solution asi class 10 higher mathematics board of secondary education Manipur की solution ने. Chapter transpose of a matrix solved and presented by Salam Megasundar Singh, lecturer Susana Higher Secondary School in Pan. Transpose of a matrix. Matrix samagi transpose. The matrix obtained from a given matrix A by interchanging the rows into columns and vice versa is called the transpose of A and denoted by A dash or A to the power T. Pavamatamda it must be read as A transpose. Apiba is A have a matrix amagi rows in a columns in the columns in a rows no pongaba matrix adubu A have a matrix asigi transpose kowi masibu A dash natraga A to the power T na khangnagani Paba matamdadi A transpose and a pagani. Easy. 1, 2, 3. The Sigi 2 by 3 matrix Sigi transpose dash the PG transpose havedi first row asina first column lakani second row asina second column lakani or first column asina first row lakani second column asina second row lakani third column 3 6 asina third row lakani. Theorem. For any matrix A transpose of transpose is A itself. Transpose की transpose की A तांगने है बस proof तोक्सी matrix अनिसी माने हर बदी आहान बदो order माने है proof तोक्सी. Let A be a matrix of order m by n. A have a matrix असी की order सी m by n है लोक्सी से. Then A transpose is a matrix of order n by m. A गिने m by n और बदी A transpose की दी n by m और ने. अमुक्सु similarly A transpose of transpose is of order m by n. मतलब कि n by m से अमुक order होंगे m स्मूला करने रोने स्मूला करने. Hence, a transpose of transpose in A are of the same order. हाइवेदी matrix and इसी order माना रहे. A हाइवे matrix की order सी सी अजुआ A transpose की order सी अनिसी माना रहे. A की order ना m by n A transpose की order से m by n अनिसी माना रहे. Then next corresponding elements माने हैं proof toxi also ith element of a transpose of transpose. A transpose की ith element अदु जे ith element of a transpose और हम जिसी transpose लोग तरह कोने ना सीगी जे ith element of a transpose को माना गया अमुक्सु A की ith element को माना गया. Ith element of a transpose of transpose is equal to ith element of A. A की I super column दलेबा I super रोगी जे super column दलेबे element असिगा A transpose की सी की I super का रो दा जे super column element का माना रहे हाइवेदी corresponding element सिंग माना रहे. Hence A transpose of transpose equal to A. मर्मदी और अनि सी order माने की बनी corresponding element सु माना रहे matrix अनि सी माना रहे. Hence proof. Theorem. If A and B are matrices of the same order, A plus B transpose is equal to A transpose plus B transpose. Transpose of the sum of two matrices is equal to sum of the two transposes of the matrices. Let A and B be matrices of order m by n. A among B C order m by n level matrix so that A plus B is C conformable with the amount. Then A plus B whose transpose and A transpose plus B transpose are of order n by m. A plus B की transpose ना m by n और A plus B की order ना m by n और मधुर transpose लोड मधुर की matrix की order n by m और then A transpose plus B transpose A transpose the n by m ni B transpose to n by m ni order माना बा matrix ni finality अमुक से हाने की matrix अधूरी order का माना करें n by m होएगा. Hence A plus B transpose equal to A transpose plus B transpose of are of the same order. Matrix and its order सब माना रहे. Also ith element of transpose of A plus B is equal to j ith element of A plus B. Then C अमुक C j ith element of A plus j ith element of B. Order is माना C C transpose over the ith element of A transpose plus C transpose over the ith element of B transpose. the ijth element of A transpose plus B transpose to sum up the corresponding elements into manare. Already hana manare corresponding element manare and is considered. Hence, transpose of A plus B equal to A transpose plus B transpose. Hence, proof. If K is a scalar, then K A transpose is equal to K into A transpose for any matrix A. If A is of order m by n, then both the matrices K A transpose and K A transpose are of the same order n by m. Matrix and is order C n by m order manner. Also, ijth element of K A transpose equal to jith element of K A. Then C K semo kamalo to jith element of A. Then K into I to ij element of A transpose. Transpose already corresponding elements in a video positions of the interchange down. Then ij element of C case में A transpose को बना संख्या से ij or element of K A transpose. Hence, these two order the matrix and its order Hanamana corresponding elements one array and the K A transpose is equal to K A transpose. Hence, proof. Theorem 5. If A and B are conformable for the product AB, then transpose of product AB equal to B transpose into A transpose. Let A be of order m by n and B be of order n by p, then A product AB is order of m by p. A have a sin m by n or a B have a sin n by p or a han sig n manable maram the product AB is conformable for multiplication. Then Mahaki product amok sig n and is skipped out for the m by p or a. And the product AB is of order m by p, so that AB transpose is P by M. Again, B transpose is P by N matrix, while A transpose is N by M, so that B transpose into A transpose is M by P. Whereas B transpose and C B transpose की order na P by N, A transpose की order na N by M, N and C मान हाली दूसरी होरें B transpose into A transpose to M P by M ताना ना बगिलमा. Hence, transpose of product AB and B transpose into A transpose are matrices of the same order matrix and is order manner corresponding to the proof to also ij element of transpose of product AB is equal to the ith element of AB. A product AB transpose or ij element adu product AB is a ith element ka managan. Then inner product of the jth row of A and ith column of B. The inner product of ith column of B and z column of A. Inner product of the ith row of B transpose and z column of A transpose. Then ij element of B transpose into A transpose corresponding elements manare adu order so hana manare and is lagadi. Hence, transpose of product AB equal to B transpose into A transpose. Hence, proof. Symmetric matrix. A square matrix A is said to be symmetric if A transpose equal to A. That is A of suffix ij equal to A of suffix ji for all I and j. Square matrix ama symmetric way hagan mahaki transpose ma samak tarabadi natragana elements in the hierarchy I to row z suba column element aduga z suba row I suba column element ga mana kadabani masi I ama j gi bulu puna makta chumadabani. For example, sigi ahan but 3 as let's see sigi 3 as column order late sigi 3 as a1 2 ni a1 2 sigi 3 a2 1 suga mana C 4 C A of 1 3 ni CD A of 3 1 so CD A of 2 3 ni CD A of 3 2 ni ani simane diagonal level elements in CD adum oning bo idarasa CD oning bo idarasa. Skew symmetric matrix. A square matrix A is a skew symmetric matrix if A transpose equal to minus A, that is A ij equal to minus A of J I for all I and J. Square matrix amagi transpose na minus times of A phanglabati skew symmetric matrix haigani haibadi I super row gi J super column level element aduga J super row gi I super column level element toga ani do amana amagi sign da edit honorable same super opposite sign honorable suppose sigi A of sigi A of 1 3 siga A of 2 1 siga ani sa amana magi repeat inverse so sine A of 1 3 ni sine A of 3 1 ni same gonna super opposite sign sine A of 2 3 ni sine A of 3 2 ni ani sa amana magi repeat on origin then diagonal riba then diagonal of principal diagonal riba for putting up 0 ni let's see how we see. Prove that all the diagonal elements of a skew symmetric matrix are 0. Skew symmetric matrix samagi diagonal element punamak 0 hoigani. That is proof. Let A be a skew symmetric matrix. Skew symmetric matrix samalorasi. Then by definition of this definition A of suffix ij is equal to minus AJI for all I and j. For diagonal elements I am assuming diagonal hybrid repeated suffixal diversity diagonal probability I am assuming the Romana J Kurumak I sindocravity method it becomes the right to left tongue or similarly for Matmafama for all I harani I N J Kurumak I sindocravity J later vanina for all I harani. Then CDAI equal to 0 and for all I know 1 1 or A1 1 0 A2 2 A3 2 0 and thus all the diagonal elements of a skew symmetric matrix are 0. Skew symmetric matrix some of the diagonal element punamuk 0 even have the promantor. Prove that any square matrix A can be expressed as the sum of a symmetric and a skew symmetric matrix. Square matrix A kudumak symmetric amaga skew symmetric matrix amaga ani sum the pongo pi promantor. We have A equal to half of A plus A transpose plus half of A minus A transpose. A haribi square matrix assume EBI mathematically assume then the ahan C half of A plus A transpose ki transpose low C then K times of it K A ki transpose K into A transpose ni C ki theorem chi sirinaragadi K ki value half or a half length lerane ani suba matrix asida transpose learning samgi transpose the A transpose plus A transpose of transpose sig property sinani matanda transpose ki transpose the masamak learning sig property theorem sig matun sin A phangani matrix addition is committed to ana kon thong si A na mamang tang si A transpose na simlak si but remember half of A plus A transpose ki transpose na masamak tarabadi pyramidal matrix as a is a symmetric matrix first class symmetric or similarly ekuna amukso ani suba sig transpose log si hanagi property to pansi half A minus A transpose pang transpose already A transpose atang A transpose of transpose pange sig properties matun sin A pangani sig properties matun na v minus common log si karigumba matrix amagi transpose na minus times of masama pangabadi hanagi matrix adi skew symmetric matrix or hence A can be expressed as sum of a symmetric and a skew symmetric matrix hamlo pongwa. Exercise 5.3 Transpose of a matrix. Exercise 5.3 then in a see transpose of a matrix ki mari le na question singa don. Write the transpose of the following matrix masi makha matrix sig transpose to hibernate. Pyramid matrix sig transpose the first row the lady but 2 is the first column the lady second row the lady of element asina second column the lady. Then similarly mathangi susu first column asina first row the lerani second column asina second row the lerani ahum subag si asina first column the label first row the label asina first column first row the label asina first column the lakane this must be 3 oigadoban c 3 oigadoban c first row asina c 3 oigadoban then second row asina second column the lerani second row asina second 0 1 4 0 1 4 sina lengana thamani asina Roman number 4 transpose of this matrix state first row asina first column the lerane first row asina first column the second row na second column the third row na third column the lere so na last matrix see the first row asina first column the second row asina second column the third row asina third column the lere verify that transpose of A plus B is equal to A transpose plus B transpose when A and B is high manabane sangakani verify chumi ukadabani akanaba problem sina hanegi theorem is proof to correct when A han bada A plus B putokan sina phange amuk transpose law badi first row is na first column the second row is na second column the second row is second column the legedabani mark the makta is the three lady will see 3 4 3 sina 4 3 4 5 sim this must be over so next A transpose plus B transpose A transpose C transpose T 1 2 na first column la kani 4 3 second column da B transpose to 3 1 na first column da 0 2 6 adding to anisimana re anisimana rabanina hence this equal to this is verified. Roman number 2 so chamana among the A plus B hana putokani matana transpose logani then A transpose plus B transpose ki value putokani matrix ani asimana rabanina matrix ani asimana re hence this is verified semiola. Roman number 3 A plus B hana putokani A plus B puto A plus B puto C pa so transpose amulo de first row 3 2 0 minus plani 3 4 parts in a second 3 4 parts in a second column da 7 1 4 in a second column da lani mathang da A transpose sum to B transpose A transpose ki value yeng aga direct thama do B transpose ki value lewa sum up to phange right up phange the matrix and its value chap mana and this equal to this is verified. Verify that product AB transpose is equal to B transpose into A transpose value my ulu have an AM to be the pharmacy of Matanda. The product AB pang tokani we get this sipang then Masigimu transpose already first rows na first column the second rows na second column next B transpose into A transpose B transpose ki value C transpose is pangani B transpose to simani ma so multiply to same value pa right and simana left and simana third product AB transpose equal to B transpose into A transpose is verified symbol. Then product AB hana pang tokani product AB multiplication pang to S pang then its transpose is the first row first column second row second column. So B transpose into A transpose tokani pole and its right and its manner therefore this equal to this is verified symbol. Roman number 3 on with the product AB tokani next Maduga transpose logani 117 first column the lakani 111 second column the lakani matanga B transpose into A transpose direct delete zero multiply to system lere right and simana delete animana the therefore product AB transpose equal to B transpose into A transpose have sum ule manago for on bada product AB tokani matanga AB transpose amuk tokani then B transpose na A transpose to puriro actual multiply to same and right and its manner therefore this equal to this is verified to me. 3 verified Roman number 5 some number process ni ahan bada product AB putokani matang the AB transpose also B transpose into A transpose matrix and its multiply to so we get this right and its manner therefore left and its manner this is verified. If A equal to this and B equal to this, verify the following: A transpose or transpose equal to A plus B transpose equal to A transpose plus B transpose. A transpose in this must be equal to equal to then A transpose to A transpose ka amok sige transpose to receive panganin this is A again and A transpose of transpose is A hence verified. Then matang idi ahan bada A plus B hana putokani we get this sige amok transpose law over the first one of first column the second one of second column the later Next, A transpose plus B transpose token sum of the right and is similar. Therefore, A plus B transpose equal to A transpose plus B transpose is verified. Twice A, Matanga Ahan, but the twice A put open to an element to Namuku, we get this. Masigamu transpose chlorobody, first row, first column, second row, second column. Next, 2 into A transpose, 2 into A transpose is this. Put in the body, right, and is similar, left, and is similar. Hence, this equal to this is verified. Similarly, Matangi product AB Hana Photocani, you are in the transpose of logani. Also, a B transpose, A transpose of Pol Pol and is similar. Hence, this equal to this is verified to Express the following matrix as a sum of a symmetric matrix and a skew symmetric matrix. C matrix is sum of two matrices, the Pongo matrix and a symmetric, a skew symmetric. The pyramid matrix A C A transpose looks a loss to. Then we have learned that A equal to this plus D. And by the half of A plus A transpose the value put to which is symmetric for Pomanamina. Then half of A minus A transpose the value put to the additive inverse or a diagonal element zero skew symmetric matrix. Therefore, given matrix is sum of a symmetric matrix and a skew symmetric matrix. Similarly, 3 by 3 same process. On the A coordinate matrix C A coordinate A plus A transpose put on its fangane. Then C symmetry or a 3 minus 2 6 is diagonally when you voice no. Symmetric matrix then half must half no more coincidence so more. The A minus A transpose for Kayong and Sipange, a half of both sides of the symmetric matrix diagonal element for 0 matrix and C element and C semi but opposite side 0 minus 1 say skew symmetric matrix. Therefore, given matrix is sum of a symmetric matrix and a skew symmetric matrix. The process of the key minus son of Pankokani A plus A transpose pyramid C E and a Kaurani Aduga A plus A transpose to Tokani half na Purichilla Matung Su, which is a symmetric matrix. Matanga A minus A transpose to Tokani half na Purichillani skew symmetric matrix. Sorry, I'm line a Kanga. Maramad pyramid matrix such as sum of a symmetric matrix and a skew symmetric matrix. For any square matrix A, prove that both the product A transpose and A transpose A are symmetric. I've seen any square matrix or a pyramid matrix and is symmetric or will have any. We have to apply property and pyramid matrix transpose logani. But transpose the aqua matrix transpose the mamang tangani, a matrix transpose of transpose the maning tangani. Then transpose the A have a famous theorem similar to an A panga. Ojik Mahaki transpose the masama panga. Pyramid matrix A transpose into A is a symmetric matrix. So no matang is some upang tokane A transpose. A transpose lower A transpose ki transpose to supangane. Then CDD transpose ki transpose A lere. Masama ki transpose na masama pangavadi masi symmetric matrix. Hence proof. If A and B are symmetric matrices of same order, so that A plus B is symmetric. Symmetric or A must be the symmetric matrices A plus B is symmetric organ minus organ. It having spiral by method for A plus B transpose the A transpose plus B transpose A transpose the A is symmetric organ B transpose so B is symmetric organ. Masama transpose na masama pangabadi A plus B is a symmetric matrix. So minus kid is some other process the Pankokani, then AB is a symmetric matrix order. Similarly, Roman number 3 A Amazon B is symmetric matrices of same order and show that this is symmetric C transpose from glory and C symmetric matrix or minus C transpose glory the addition the 100 matrix transpose plus an matrix transpose. For the transpose the B transpose no among Tangani A transpose no polar. So na A transpose na mamang pangani B transpose na polar. Makoy kujung matati condition superior asuna pang. Si matrix addition is a specific commutative or mission mamang lagla. Masama ki transpose na masama pang ado pyramid matrix as symmetric matrix. Similarly, minus ki ku ko na mata ki se chap ano mong da pang tho ga ko na masama ki transpose na si minus lo ko minus times from masama phang abadi skew symmetry matrix sore pyramid matrix skew symmetry matrix sore. So that the matrix this must be transpose or given its bonds. So that the matrix A B A transpose where A B are square matrices of the same order is symmetric and or skew symmetric according as B is symmetric or skew symmetric matrix. Let's see. Iron matrix transpose looks the A transpose ki transpose mamang thangani A B symmetric samani khalaga mapumoine product A B ki transpose maning thamo transpose A transpose or transpose the elere matrix ani B transpose to B transpose mamang thangani A transpose no color assume B transpose as C B in single B in symmetric already B transpose as C minus B in single B in skew symmetric matrix already minus a common law to see masama ki transpose na masama pangabadi B in symmetric matlab masama pangi aro masama ki transpose na minus times for masama pangi B in skew symmetric matrix already. Thus product A B A dash is symmetric matrix A B is symmetric and also is a skew symmetric matrix A B is the skew symmetric matrix henceforth. If A and B are symmetric matrices of the same order, so that product A is symmetric if and only if product AB equal to BA. Ani proof to one equal that product AB equals to BA man and say A product AB transpose product B transpose into A transpose. If B transpose to B in single A transpose to N single C matung api bagi matungina then CD matrix multiplication and C maning condition apiba condition supposition ni matungina B A bu A B ni single masama ki transpose na masama phangabadi matrix A B product A B is symmetric if A B equal to B A. Conversely, suppose A B is symmetric A B is symmetric na hanelo si masi ki transpose to masama karani adi A transpose bi A D A transpose na single ni masimana bani B D B transpose na single ni amok sidagi B kamal log ko obadi B A transpose log silani then transpose and is equal to A B equal to B A ka mana hai hence proof.